Let's go ahead and solve the very first type of one-step equation. One-step equations are called one-step because they only take one step to solve. And you might be able to already tell what x is going to be. We're asking ourselves, what plus 4 equals 10? And that gives you a little sneak preview into what the answer is. But in order to do much more complex equations, we have to understand the idea of inverses. There's lots of inverses in mathematics, and this one is going to show you the very first one. Inverse means opposite operation. And so we have addition here, and the opposite operation to addition is subtraction. And you can think about inverses like the Control-Z button or the undo button. Addition and subtraction undo each other. So an equation is very much like a balance on a scale. We need to make sure that we are doing the exact same thing to both sides. Although it is very simple right now, I really like to show my students to put a line where the equal sign is. This sets you up for the right idea. That line is going to represent the equal sign all the way down. We're never going to move the equal sign. Not really. We can do stuff on the left of the equal sign, and we can do stuff on the right, and we can move things across the equal sign, but that equal sign is our balance point, right? It's the point at which we make sure that both sides of the equation are the same. So now let's go ahead and get started with understanding what do I do with this inverse if I'm doing inverses and I want to show that subtraction is undoing addition. How do I do that? So we have x plus 4. In order to undo the 4, I am going to need to subtract 4 from both sides, like this. 4 minus 4 is going to turn to 0. So this is how I know that this is going to be canceled out. I can treat this now like a vertical addition problem. X plus nothing is x. 4 plus 4 is 0, so that just disappears. Our line, remember, is always going to represent our equal sign, and 10 minus 4 is 6. So therefore, the answer that we get for this problem is x minus 6, like this. So without any of the extra fluff of explaining, let's go through those steps again. First, we anchor our equal sign. Then we identify what are we undoing. A positive 2 plus 2 has been added to the x, so we have to undo it by doing the inverse on both sides. That's going to mean subtracting 2 on both sides. X plus nothing is x. 2 minus 2 becomes 0. The equal sign stays where it is, and 7 minus 2 is 5, just like this. Now I'm going to go ahead and do 2 more examples. Let's erase most of this board. And there we go. Now you'll notice maybe right away that I have one example that looks just like what we were just doing and another one that is all mixed up. And so I'm going to show you in just a moment how to handle that. So we have x plus 1 equals 9. And remember that we want to anchor down that equal sign by making a line. I notice that the operation that's happening right now to the x is a positive 1, so x plus 1, so I am going to subtract 1 from both sides. That's the inverse that I'm using here. X plus nothing is x. 1 minus 1 cancels each other out. The equal sign stays where it is, and 9 minus 1 is 8. So my answer is x equals 8. Now the reason that I'm showing you an equation that looks like this, and even we would be able to even mix it up further by showing you an equation like this, and in fact I might do a couple problems after this that look like this. A lot of my students learn this and then they see an equation that's all mixed up and they don't know what to do. And I tell them, well, you always know your very first step. Your very first step is anchoring down that equal sign, just like this. Your second step is to orient to where the x is. Our x is right here, and this is what's happening to the x, plus 6. And so that's how I know that I am going to subtract 6, just like this. Subtract 6. Because the x is over here, it's the plus 6 that I need to move. It's a very common error, and I do have a whole series of common errors, to believe that you need to do something with the 4. You don't. It's kind of like the x is having a party, and he's telling everyone to get out. He wants everybody to leave his side of the equation. He's done, he's tired, he's kicking people out of his house, and that side of the equation is his house. So you don't need to move the 4, you need to move the 6. Okay, so now that we have done the inverse of plus 6, we're going to still treat this like a vertical equation, going left to right. 4 minus 6 is negative 2. Equals x plus nothing is x, and 6 minus 6 cancels each other out and is 0. Now, if this negative tripped you up, you might want to visit my series on integers. If you're learning this as a younger student, a 4th grade or 5th grade student, integers are in your future, and most of the problems that are in this video aren't going to deal with negatives. Let's go ahead and clear the board again. And here we go. So you can see now I've given you another problem that looks just like the one from the other side, and then also one that's even further mixed up. And since we already know what to do here, I'm going to solve this really quickly, and then I'm going to show you a trick. So of course we have plus 3, we've anchored the equal sign, this is the x, so it's negative 3 that we are putting here. 8 minus 3 is 5, equal sign is always here, x plus nothing is x, and 3 minus 3 cancel each other out. Therefore, my answer is x equals 5. Now, as promised, I'm going to show you a trick, and this really doesn't work once you get into much more complicated equations, but it can work to get you familiar with equations right now. Because we anchor this equal sign, we can actually spin this equation around. As long as we write exactly x plus 3 over here, and keep our equal sign here, and 8 over here, we can move this around before starting to do the inverses. Now, if you're really struggling with one-step equations, this might be a good trick for you to use for just a little while until you get more familiar with it. Eventually, you will need to solve equations that have x on both sides. All right, so let's go ahead and tackle this. I am not going to do the spinny thing over here so that you can see exactly what happens and how you can work with this equation in its form right now. So I'm going to notice that, okay, we have the 9 here. We're orienting ourselves to the x over here. Okay, so I know that I have to kick things out, right? Get out is what he's saying. Get out. And the only thing that's sharing this side with him is the 2. But there's a plus in front of the x, and there's nothing in front of the 2. So what do? A lot of my students assume that this sign belongs to the 2, but it does not. That sign belongs to the x. This is a plus x. What's in front of the 2 is an invisible positive or plus. And this is the sign that you need to use. That's very important because later this isn't always going to be an addition sign here. So you don't want to get confused that this addition sign belongs to the 2 because it does not. It actually belongs to the x. Now that we know this is a plus 2 or a positive 2, remember its inverse is still negative 2, or subtracting 2 from both sides, which is the same thing. Now we're going to treat it just like a vertical addition sign or addition problem, just like we would. 9 minus 2 is 7, equals stays where it is. 2 minus 2 cancels each other out, and the x plus nothing is x. Now watch, I'm actually using the flippy thing at the end. This actually does have a name, and it is x equals 7. And that's our answer. This property that we've been using to help us flip the two sides of the equation is called the symmetric property. Now at this level, I don't necessarily think you need to remember that that's the symmetric property. You just need to know how to use it. Later, when you get into pre-algebra and algebra, they're going to ask you to prove how you can flip the equation around, and you would need to use the word symmetric, but not right now. Good luck with those equations.